In order to find the area or probability between standard deviations, known as a z-score, you first have to use the formula that z is equal to x, the data point, minus the mean divided by the standard deviation. And that will come out to a value that will be some kind of decimal. If it comes out to an integer, you've actually found an actual standard deviation. But if it came out to something like 1.80, then you found a z-score, which is a value between standard deviation 1 and 2. So we can look this value up on a table, and that table will give you the area below the z-score. And so here's a little snippet of an example of what this looks like. If I take 1.8, the concept is that it's the area below this curve. If it says find that, you could find the area above. And the way you do it is you start on the left side of the table and you trace the 1.8 until it intersects the second portion, in this case, a 0. And then that intersection of those two values right there would give you the area that goes from this value to negative infinity on the sigma axis. And then that value is also what's known as a probability of 0.9641, or a percentage of 96.41 if you multiply this by 100 and move the decimal place over 2. So that's how you would typically do it, but the chart usually looks a little bit more involved like this. This is the chart for the standard normal probabilities for the SOL in Virginia. Notice that it's stating to you that it's the area below, and you have a chart, it looks like this, and let's say somebody were to say, I need you to find the area for a z-score of something like 0.34. Now, to explain to you what this means, this is not the kind of decimal that you think it means. It doesn't mean 0.34. It is a value that represents, okay, if the mean is 0, representing 50% or 0.50, 0.34, right, this would be 1, 0.34 would be in here, and we're actually going to find the area that represents this much of the curve. So it's actually something above 50%, or something above 0.5. So let's take a look at what this would be. We'd go to 0.3 here, and we would scroll over with our pencil or our finger, or if we're lucky enough to have a highlighter, all the way over to 4, and then we go down this way, and where they intersect is the value. And it makes sense after I explain it to you that this would be bigger than 50, so it's actually 0.6331, or 63.31% of this area, or of the data is what statistics would call it. So, you can do this with a larger number if you want it. It doesn't have to just be this small. And it could also be a negative number. And a negative number would be represented by, normally there's a back to this sheet, and that gives you the negative numbers. So let's say, for instance, that somebody said, you calculated more like, use that formula that I showed you. And we'll do actual problems once we learn how to use the chart. Right now, we're just trying to learn how to use it. So let's say we had negative 1.57 as our z-score after we calculated it. So you can see this one starts at negative 3.4, and so we'd have to scroll down until we found negative 1.5. There it is. And then what we would do is we would highlight negative 1.5 until we come over to the 7 at the top. So you kind of just eyeball it right about maybe there. And then I always tell students, make sure by coming down this way and finding that intersection. You can see how highlighters are a great way to do it. Again, you could use your pencil or just a sheet of paper. And so this comes out to 0.0582, or 5.82% of the information would be below this. So if this z-score represents your shoe size, then only 5% of people would have a shoe size smaller than yours or below it. So students will always say, well, why isn't there a chart for above? Well, there really is. You're actually looking at it. So let me explain how to do above on a chart. The way you do that is, let's say, again, this value that we looked at originally that you can see right here is finding the area below. But if I wanted to find the area above this, what I would do is I would simply come to my chart and say, okay, I have the same z-score, but to find it above, you just add a negative to it, because you're think about the idea that you're really just doing the inverse of the area you're looking at. So if I wanted to do this one, it would be above. If I use the chart the way it's designed, I find below. And then what I do is I just flip the chart over. So to find this above score, I just flip the chart over and find 0.3 negative right here, and then the 4 over there. So you just use the exact same way, understanding as a human what you're actually doing. And then what you find in this case, right, you need to go over to the 4. Again, I don't quite know where it is, so this is the downside of it. You're kind of having to scroll around and just make sure that you have found the right value, and then I'll explain why it makes so much sense. So you end up getting 0.3669 or 36.69%. Now that number and the number we found here add up to 1. 0.3669 and this add up to 1, which understands that if I look at this, that is everything. So the value you get correlates to the left side of the chart. Putting a negative on it gives you kind of like a trick to find the above part. It also works for the negative. So if this value right here is a below value, right, then finding the opposite or the addition of the positive version of 1.7 would find above. So let's go see if that works. So here we had this very small value of 0.582, which is about 6%. So the other one should be 90 something. So let's see if it works. So we're going to go back to the other side, find 1.5 here. So 1.5 here, and then we're going to go over to 7. All right, and I guess, again, it's maybe here-ish. Let's go see if I got it. So it looks like I did find it. And again, 0.9418 is the value above the z-score at negative 1.57, and that value plus that value right there comes out to 1. So that's pretty neat how that works. What this chart does not do is it doesn't help you ever find values between. I mean, not directly. You can do it indirectly. So let's say you wanted to find something that was between 0.34 and negative 1.57. That would be, thinking about it, that would be like finding this value here, and this chart cannot do that. And the way you would have to do it is you'd have to actually take your values that you found here. So you'd have to take 0.6331, and then you'd have to, write that down and then subtract out the smaller piece, which was 0.582. So literally you'd have to do that manually. You'd have to take this value and then subtract out that value. And that's why we are glad we have a calculator to do this as well. But the chart does have its place in terms of looking up below values and above values very quickly.